thanks to Donovan to lend us his branch to do that. My presentation isn't going to get very, very technical. I want to leave that up to the questions. Otherwise, we end up with half the people falling asleep because they're actually not interested in the technical side of things like inverters and whatever. So what I'm going to do is go through general dual battery systems, some of the pitfalls in the systems, what you should look out for, how you should wire certain things up, and the advantage of wiring in certain ways. So we'll cover it from that angle, and then, as I said, if you want to start asking tech questions, we'll do that at the end individually, so we don't lose everybody. Okay, so a basic dual battery system. Can everybody hear me? We're okay. A general dual battery system. You'll have a starter battery, okay, which feeds into your DC charger. The DC charger will then charge up your dual battery, your second battery, your auxiliary battery. Okay, it's obviously right to put a fuse in place, okay, on both lines. From there, and this is a very old board that we've got here because this has now changed the way we wire. Okay, and I'll go through that. And the other thing I want to go through is obviously the colouring of plugs as well. That's also very important. So your DC charger will charge up your batteries. And this is obviously, again, the wrong battery to use. You need a deep cycle battery. And then from there you'll go to your accessories, and your inverter will always come directly off your battery as well. Okay. Important to know that the inverter is only a switch box of power. It converts your DC to AC power. It doesn't give you the longevity of running your accessory. That comes from your batteries. So if you're trying to boil a kettle with a 60 amp hour deep cycle battery, your battery ain't going to last. Okay? Your kettle is going to drain 2,000 watts of power, and you've only got 60 amp hours available. Okay? So it's important to know, if you want to run a big inverter, you want to run a coffee machine or something like that, the selection of the inverter is very important, and we're going to cover that. But always remember, if you're going to run heavy power, you need lots of batteries to support that power that you need. The inverter doesn't give it to you. The inverter actually takes a bit of power away from your battery. Okay, so you've got a starter battery and you've got a solar panel that will feed the DC charger. Most DC chargers do have a PV input. From there you're going to go to your auxiliary battery. Now, the way DC chargers can be set up, ours is variable. You can set it up either way. But when you turn your car off, which is your DC input, your PV power, which is your solar, will then take over. Okay, so you'll have a constant stream of power coming in, obviously as long as the sun's in the sky. That then goes to DC to auxiliary battery. Your auxiliary battery then splits to what we call a tech hub now. Now Megaworld have had a tech hub available for a while. Okay, they call it a link system. We now have introduced a similar type system. And what that does is it clears your battery of all these, and you can have a look afterwards. There's 4 ferrules, well not ferrules, what do you call them, lugs, on per battery terminal. Now if you go the tech hub way, first of all you save a lot of cabling, because you've only got a positive and negative going to your battery. Thereafter, everything else is wired into the tech hub itself. So all your accessories run out of here. Now this one in particular is fused and relayed to 20 amps. It's got 2 20 amp terminals. It's got 2 5 amp terminals, 2 3.5, 2 1.5, things like lighting and whatever, LED lighting. That can be operated either on a switch or you can operate it on a remote. So when you're sitting in your rooftop tent, you're wondering now who's going to go downstairs to turn the light off, just pick up your remote and turn it off. Okay, simple as that. So this is a much more economical way of looking at a central distribution board at the end of the day. You're not overloading your battery with all sorts of cabling. It eliminates the need for a switch, and it eliminates all that wiring going to your batteries. Okay, so all the wire just goes into this. Okay. So that would be the tech hub. Your inverter, you wouldn't wire through a tech hub because it's only 20 amps as max. Even a small inverter could take up to more than 20 amps. Okay. And then off the tech hub, you would run accessories 20 amp and under. Are we all okay there? Okay, the next slide I want to look at is panels. I want to talk about panels because there's a lot of misconception about panels. We only sell the one panel, and that's this flexible 6 amp panel. All right. It's light. Okay. It's flexible. It's durable, and more importantly, is that it's a monocrystalline panel. The difference between a monocrystalline and a polycrystalline and a multicrystalline panel. The monocrystalline panel is the most sensitive panel you can get. Okay? Polycrystalline is the least efficient. That's at the other end of the scale. Now, polycrystalline you'll find a lot in industrial and domestic type solar applications. And the reason why they use an inefficient type, not inefficient, it's a cost-effective way of doing it. You've got the space to add another 2 or 3 panels to make up for the loss. Okay? Whereas this kind of panel, you're fighting for space the whole time, which is why it's so thin. Alright? Now, the equivalent polycrystalline panel will probably give you about 4.5 amps at best. This will give you just over 6 amps at best. Okay? Important to know that if you have to rupture one of these cells, it doesn't take the whole panel down, whereas polycrystalline does. If you crack that polycrystalline glass, that's the end of your panel. You can throw it away. Okay. This one will just lose a bit of efficiency. You'll lose the one cell. The way the electronics are wired up, okay, it allows you to lose 1 cell, 2 cells, 3 cells, 5 cells. But the rest of the cells will continue working. Okay? Obviously they're a lower production because it's a very specialized market. Okay, and not everybody in the world likes overlanding and 4x4ing, so it's a small market compared to normal solar panels. So they are expensive from that point of view. Obviously the technology is a much higher level as well. Now, when it comes to wiring in panels, do not cut these off. You can if you want, but I'll tell you why not. Okay? If you've got one panel, okay, rather make up a short cable with 2 extra plugs like this, okay, to a square connector plug, because that's what everybody likes to use, a square connector plug. Okay? And solar is blue. Anything to do with solar is a blue plug. Okay? When it comes to electrical work, all electricians, whether it's for domestic, whether it's in your car, all your wiring is color-coded. And it's color-coded for a reason. Now, we put an initiative out 2 years ago through SA 4x4, and in conjunction with the biggest importer of these plugs, which is Lumina, and National Luna, in cooperation with them, to start promoting the fact that there are 3 colors, because everybody used to use the grey plug. Nobody used to use the rest. Okay? And the problem is when you sell that car, or somebody else wants to use your car, or whatever, you could end up putting a solar panel into where a charger should be going. So you could you could end up blowing up stuff. You could be putting it into an output instead of into an input. You sell the car, the guy's now got a wiring nightmare to look into and fix and sort out to ensure, so he understands where this wiring is going. Okay? The difference between the grey and the red is the direction of current. Okay? So red goes into the battery. Grey comes out of the battery. So grey is what you'll plug all your accessories into. Red is what you're feeding the battery with. So if you're plugging your trailer into the car, and you've got a DC charger at the back in the trailer, it'll be a red plug at the tow bar. Okay? All the way along the line until you get into the battery will be red plugs. Okay, that'll eliminate people plugging in things that shouldn't be plugged into places and blowing stuff up. Okay. Okay, so let's get back to the wiring over here. So you'll make up a short cable with these plugs on the end. Okay, so you'll have a short cable, only has to be about this long, with solar plugs on the one side and your blue square connector on the other side. Why do I say that? Because if you want to add another panel, all you need to do is unplug that, plug that into there, and that goes onto your short cable. Now you've got a 24 volt system, okay, but you're now running 2. It's actually more than 24 volts, but you're now running 2 panels, and all you did was unplug one plug and plug it in. No change. Okay? You would also obviously make up a longer cable that runs from the end of that short cable you make to your car. So you can make up an 8 to 10 meter cable as well. But that'll remain common, no matter how many panels you have. Okay, we understand that? Alright, so that's just a tip. Otherwise you end up cutting this off. Put a square connector on here. Now you're going to connect up another panel. Now you're cutting off the square connector to wire in another panel. There's 2 ways of wiring in panels, okay? In series and in parallel. If you're going to have a portable system, in other words, you're not going to mount it permanently, I would suggest in series. In other words, you're plugging in the positive and the negative, which leaves you a positive and a negative to plug into your DC charger or your controller. Alright? If you're going to have it permanently mounted and you've got a problem in terms of the capacity of your DC charger, and we're going to cover that just now, you might have to wire in parallel. Now, to wire in parallel means that the positive and the positive has to be wired, and there is a plug that you can get that you can put two positive plugs in and 2 negative plugs in. Alright? And then you've got your positive and negative that will come out of those plugs. It's a bit of a wiring nightmare if you're going to have it loose, because you've got wires all over the place. Which is why series is much better. Okay, but you've got to have the capacity in your DC charger or your controller for that, because you're doubling up on the voltage. Okay, and as I'll show you just now, there's not a lot of DC chargers around that can take 2 panels. Okay. Okay, so the importance of using square connectors, we've gone through that. Blue is solar, red into the battery, grey out of the battery. Okay, so grey is where you'll plug in your compressor or whatever you want to plug in. And we've covered the solar connectors. Are we all happy with that? DC charger. Basically what a DC charger is it takes 12 volts coming in from your alternator via your main battery. Alright? And basically becomes a normal charger that then puts out your auxiliary battery, and all of them are smart chargers, so the voltage does regulate itself depending on how full the battery is. Okay, your battery will give you a charger resistance, and that resistance will determine the amperage that goes into that battery. Okay, if you look on the bottom over here, there's 1, 2, 3, 4, there's 5 different DC chargers on the market. Product 1 is a 25 amp DC charger with 27 volts PV input. Okay? 1 panel only, unless you're going to wire in parallel. The second product, 25 amp DC input, 32 volts PV. Unless you're using 2 smaller panels, you'll only get away with 1 panel. Okay? Unless you're going to wire in parallel. Product 3, 32 amp with 42 volts. You'll probably get away with 2. Probably get away with 2, because those are 21 volts at max, open circuit. So 42 volts, you'll be on the limit, but you'll probably get away because you're never really going to operate it at 21 volts per panel all the time. Okay. Product 4 doesn't have PV input, it's only a 30 amp input, 30 amp output, DC output. And then the Ring Automotive one, which is this one over here, is 50 amp DC, 30 amp DC. It's 50 amp input, 30 amp, that should be 30 amp. 30 amp DC output with 50 volts PV output. Okay, or PV input, sorry, I'm getting my inputs and outputs wrong here. 50 volts input. That allows you to use 2 panels in series as well. Okay, so you can comfortably use 2 panels like that. Like I say, again, if you want to have 2 panels but you don't have a charger that can accommodate, then you need to wire in parallel. And I would recommend that you mount them then. Okay, because otherwise you've got plugs and plugs and plugs and plugs. Okay. Okay, one of the products that we do very well with, because we've got one of the best available for this market, is inverters. Okay, now inverters, you get inverters and you get inverters. Okay, and what I want to show to you today is what is the difference between a domestic type inverter, not a UPS, but an inverter that you would buy from a Ellie's or a Builder's Warehouse or whatever, and one that is made specifically for fitment into vehicles. Okay, fitment into vehicles comes with all sorts of different pitfalls that you need to watch out for. First of all, vibration, different climates, all those kind of things come into the operation of these things for longevity. You pay a lot of money for these things; they need to last. Okay. We'll go through the selection of the inverter, but just from an inverter point of view, we do offer on the packaging how to select an inverter, what you can run on that inverter, and also at this point I want to let you know that there's also an app that we've created. It's the Synertec app. You can find it in either your Play Store or the iOS store, whatever they call it, for Apple, and it's called the Synertec Battery Calculator. In that app, we have available how long will my battery last? Okay, a question that we found was asked at counters, to the counter salesmen throughout the country. You guys would walk in and say, I want to put a dual battery system in, but how long is my battery going to last? And nobody could answer the question. Nobody was equipped with the calculations to be able to calculate that. So we made an app to answer that question. Okay, so by simply putting in a few variables, which you'll know because you know what you're running, it will then calculate it. It will calculate it to 50%, because we're working on lead acid, because that's 99% of the market. It will give you a calculation based on 50% drain of the battery. Now 50% drain is a safe drain on a lead acid battery. Different battery technologies, you get different drains. I mean, if you go lithium, you can drain that thing to 100%. All right? If you drain a lithium battery to 100%, you'll get about 3,500 cycles out of it. If you drain it to 70%, you'll get about 7,000 cycles out of it. Lead acid, if you drain it to 50%, you'll get about 350 cycles out of it. Now, those with calculators, do the maths. Lithium is the way to go. But you've got to spend the money up front. Okay? It's probably 5 to 6 times more expensive, but you will get your money back if you're going to keep that battery forever. Alright. The only thing with lithium at the moment is you've got to make sure you've got a charger that can charge lithium. It can't charge unless you've got a different charge controller in it that will convert the algorithm from a normal charger for lithium. You need a proper battery charger. Okay, that is lithium compatible. You'll remember a couple of years ago where cell phones were going bang and those hoverboards, but it was all happening on the charging cycle. And the reason is that the chargers they were using wasn't compatible with the battery that was there. Now, subsequently to that, lithium technology has come in leaps and bounds. They've overcome that, and they changed, I can't remember what material they were using, but they eventually went to a carbon material, and that seemed to have solved the charging problem that they had. So you won't find lithium batteries bursting into flames too often nowadays unless you're using the wrong charger. So it's important. Don't buy a lithium battery unless you can get a charger for it. In terms of DC chargers, I actually don't know of any DC charger yet in the country that is lithium compatible. Is there one?
Two.
Two?
That I know of.
Which ones are those?
National Luna and CTEC.
Isn't the CTEC one a specific one?
Yes.
Okay. So it's not a
general
new
one to the new one.
You've got to buy a specific charger for it.
Yeah, it's the new one, the new range of the 250.
Okay, all right. Thank you for that. I wasn't aware. We will have one also shortly in the next couple of weeks. It'll be compatible with normal battery and lithium. So it'll cover your AGMs. It'll cover your gel batteries. It'll cover lead acid, as well as calcium and lithium. Okay, batteries and inverters. That battery there, as I said to you, is a starter battery. Okay, it's the wrong battery for this board, but I put it up here on purpose. All right. These batteries are only designed to drain 25%. You go beyond that, you're shortening the lifespan of the battery. All right. You need to have a deep cycle battery in place dual battery system as your auxiliary battery. Obviously on your main battery, that is still a starter battery. What else is important on there? I said to you earlier, the Deep Cycle 100 amp hour battery is designed for a capacity of at least 50 amp hours. That 50 amp hours means it's 50 amps in 1 hour of consumption, or 1 amp for 50 hours, or anything in between. So 25 amp for 2 hours, okay? Anything in between that. On inverters, if we can get back to our Ellie's inverter and our domestic inverters, the ones that shall sit on a shelf and you'll use them for when you've got load shedding, whatever. Apart from things like conformal coating and all sorts of other things that these kind of inverters have, that those ones don't. The most important thing is efficiency. Now in that app, okay, that I was talking about earlier, you need to understand what efficiency is, because the efficiency of an inverter, basically that's the power it takes from your battery to run. Now a good inverter, like these ones over here, run at about 90% efficiency. What that means is it will take 10% of its power out of the battery. Your Ellie's type, and I'm using Ellie's as a brand because there's a lot of those, it could be AutoZones, it could be whoever's, but they're all the same. They run at about 65%. Now what that means is on a 50 amp hour battery, you could lose up to about an hour of runtime, just in the efficiency of the inverter. Now where we want to go, that's important. Power is important to us. Alright? If you at home, it's not as important because you're going to plug it in when the power comes on, you plug it into a charger and your batteries get recharged. But we don't have that luxury out there. So we need as much power as possible. So that becomes important, is the efficiency of the inverter, and that's where your cost comes in. Your cost comes in when you start getting more and more efficient inverters. And there's a couple of brands in South Africa that run at the high efficiency range. There's a lot of them that run at the low efficiency range. And I've seen some of them in our cars. There are some in our cars. Now in that app you need to put the efficiency in, because it's important, because that tells you how long that battery is going to last. If you're going to run an inefficient inverter, then your battery life is not going to be as long, or your runtime is not going to be as long. Okay, if you're running a more efficient inverter, obviously your runtime goes up. Okay, is that clear to everyone? What else are we going to cover? What I've done also in the app is I've included this kind of compatibility chart with the consumption. It's basically a consumption chart. So if you want to run a drill, I give you a couple of options in there, different drills, and you can then take that wattage. I built everything's in watts because that's the common value to use. But if you take like a small drill at 600 watts, it'll also tell you which inverter will work on that drill as well. Now, a drill is actually depending on the drill, is depending on the inverter. A basic drill can run on a modified inverter. But one that's got a trigger on it that is speed sensitive needs to run on pure. And the reason being is because it's got a timer in it. Okay? Now, if we go back, if we take an alarm clock, this is the easiest way to demonstrate it. If we take an alarm clock, you can see that there is a peak and a valley on a pure sine. That determines a period in time, because there's a peak and there's a valley. So when it gets to the bottom and starts turning up, that is the end of that cycle. At the top end, that is the end of the cycle. And that's what an alarm clock, as a basic, anything with a timer in it, will use to work out its own timing. It uses the peak and valley of the sine wave. Now that sine wave is what Eskom gives us, exactly the same. The square, or modified, is this one over here. Now you can see there's no peak and valley. So that alarm clock running on a modified inverter will be gaining time or losing time. All right. A microwave oven that has a digital timer, if you put it in for a minute, it may run to a minute 10, maybe run to 90, who knows, or 50 minutes or less. So it can't be exact because there's no period in time for it to read. Okay, which is why you've got two different inverters. Now, modified is a very basic inverter and is half the price of pure sine wave. Okay, doesn't matter which way you look at it, it's half the price. Okay, if you want to pick up the inverter, it's half the weight. All right, it's half the size. This here is a 2000 watt modified. There's a 2000 watt pure. Okay, pick up the box. See the difference. There's a lot more components that go into a pure sine wave inverter than there is into a modified. Modified is fine for a tradesman who gets to site, there's no power, generator hasn't got fuel in it, whatever it is, and he needs to start cutting wood and whatever it is using his saw and his drill. Perfect for that kind of thing. Perfect. But if he's got a speed sensitive drill, he needs pure sine. I've said, our guys, the most, I get phone calls. I want to run my coffee machine. 2000 watt pure sine wave inverter. Can't get away from it. It's got a timer in it. That's how you get coffee out of it. Everything's timed. Okay? So to run your 1,500 rand coffee machine, you're going to spend 15,000 rand to do it. Yes. But people do it. And you come Christmas time, we make sure we've got lots of stock of 2,000 watt pure sine. Because everybody's going away and they want their beloved coffee machine. 15 grand to run that coffee machine. Okay, and don't forget the batteries. And that is also something that we're all trying to get away from, is weight in our cars at the moment, because we're traveling at 3.5 tons, 4 tons, and we should be at 2.5 tons or something like that, 2.8 tons. And the battery is one of the places where we can save a bit of weight. Okay. But I can tell you now, it's not one battery you're going to have to take out. It's made up of a lot of little things that you've got to take out that will eventually make up that ton that you've got to save, that we are unaware of at the moment. I'm seeing that all over the place as well. Okay. Okay, so sorry, from the compatibility chart. Okay, so this is available on the app as well. If you want the app name, I can give it to you. And that will then give you, basically it gives you a whole list of components or accessories or that you guys may want to run. It tells you what is the consumption and what inverter by part number you should be buying to run that. Now bear in mind, that's only for that component. If you're going to fit out an inverter in your vehicle, please add up everything that's going to run at the same time. Okay, and cater for that. Don't try and save, because when you get out there, you're now going to want to put this in and this in and this in, and it's not going to work. So you're going to start taking things out until you get back down to the power that you can manage. All right, and it applies for home as well. If you want to put an inverter in at home or UPS, what are you going to run at the same time? I want to run my TV, I want to run my DSTV, I want to run my hi-fi or my surround sound, and I want to run a light. Add all of them together, because you're going to run all of them together. That is how much power you're going to consume. Then you also need to work out how many batteries you need. Okay, for 2.5 hours you need 200 amp hour batteries, and you'll have a little bit left afterwards. But that's for a backup system, for your TV, for load shedding, for those 4 components is 2 batteries, 200 amp hour batteries. One won't get you there. One will get you to about an hour 45. Depending on your inverter, of course, it'll get you less. How to select an inverter? It's on the side of the box. Work through it. Be honest with yourself. Okay? Be honest with yourself. What do you want to run? Alright? And you'll eventually work out whether you can use a modified or you can use a pure sine. My advice is always buy pure sine. Just buy the right size. Reason being is, today you can buy something that runs on modified and you'll get away with it. But that thing now breaks and you go and buy a new thing, and that new thing doesn't work on modified anymore. It now runs on pure. So now you're buying an inverter as well. Okay, so be upfront, buy a pure sine wave inverter. That's what we promote, not because they're twice the price, but because it's a sensible thing. If you're a tradesman, go for it. Then you need a modified inverter. You probably won't need a pure sine wave. But if you're going to run a coffee machine or anything with a timer in it, then you need a pure sine wave inverter. So spend the money up front. Okay, just some inverters. This is the small range over here for charging camera batteries, for running laptops, small things like that, drone batteries, charging drone batteries, that kind of thing. 150, 300 and 500 watts. Then on the modified side, we've got a 1,000 watt, a 2,000 watt and a 3,000 watt. In fact, there's actually a 4,000 watt as well. Okay, for the bigger guys, guys who want a lot of power. On the pure side, there's a 600 watt, 1,000 watt, 2,000 watt, and there's a 3,000 watt. I'm going to go into the accessories of some of these, because what we've done is we've developed a range of accessories as well that also control management, give you insight into what power's being used, as well as protecting batteries, that kind of thing. So I'll go through those accessories now. But just to point out, if you have a look over here, there's a panel on the 1,000 and the 2,000 watts, both the modified and the pure sine. This panel over here, which is an information panel, it gives you your battery current and all that kind of thing, is removable, and you can place it elsewhere in the car. You just need to buy a frame for it, which is available, and a cable that connects, because when you pull this out, it's obviously connected, so when you pull that out, where it connects in, the cable goes in and then goes into the back of this. And you can then mount that somewhere more convenient to the car, maybe near the back door, and the inverter can be put away. Okay, somewhere where it's not going to get damaged, not going to get bumped, where you don't have to and reach the on button. Okay, so you can put out, just make sure it's in a ventilated area. It does need to pull air in to cool the components. Okay, so what is different about our inverters, or typical inverters that are used in our industry, but they're genuine for our industry. They're not just a cheap and cheerful one that's been pulled in. They're ones that are designed for mobile use. Okay? First of all, the cables. If you have a look here, that would be a typical cable. 12.5 mil, half a meter in length. Okay? We supply 1 meter, and it's a 38 mil cable. Okay? The cables per inverter differ in thickness depending on the capacity of the inverter. Okay? You'll find when you get to a 3,000 watts, it's a big cable. Okay? And it's only a meter long, just over a meter long. So if you want to run that cable a further distance, you may have to increase the size of that cable. We've had it before where inverters have been installed in the back of the car and they're running it from the main battery, so like 3.5, 4 meters, but they haven't changed the size of the cable. It's not working properly, and it's the inverter's fault. Until they take it out, mount it close to the battery with the proper cable, and then suddenly it works again. Okay, so the further you go away from the battery, the thicker your cable, because otherwise you get a current loss. Okay. We also supply proper brass battery terminals as well. We supply protective covering. Okay, once you've connected up to the back of the inverter, there's protective covers to go onto the back. Why do we supply those? You guys have invested a lot of money into these inverters, okay, and you don't want a spanner to spoil your day. Because if a spanner hits the positive and negative, done. What I always say at fitment, take that cable and split it and fit a Brad Harris plug. So that if you're going to play with your battery, disconnect your inverter. Because all you need to do is have that negative cable hit the positive, and you're now buying a new inverter. There's no protection on inverters for, what do they call it, help me here someone, cross current.
Short circuit.
Yeah, for a short circuit, but there's another word for it. So we supply covers for the terminals at the back, in case you do drop something down there, something happens, but it doesn't protect on the battery side. So if you fit a Brad Harris plug in the middle, if you're going to play with your battery, just disconnect the inverter. It now doesn't have a relationship with the battery, so whenever what you do on the battery side, it's not going to affect your inverter. When you've finished, everything's plugged in nicely, plug your inverter back in, everything's nice. I've seen it happen where guys have short, they've polarity protection. where they've gone cross polarity by mistake, but it's cost them a lot of money. Okay, that inverter's done. Another thing that we do is all our inverters have conformal coating. Conformal coating is basically a coating they put on the PC boards, and it protects those PC boards against dust, moisture, all those things that also can create short circuits. Okay, as I say to you, if you've got a general inverter that sits on your shelf at home, not that important. Okay, but when you travel in areas that we travel into, the dust that gets sucked into the back goes into these things. You need that protection on the PC boards, otherwise again it'll shorten the lifespan of that very expensive inverter. Okay, on the accessory side, there we have that. There we have that. You can buy that separately, so that you can create that sort of on-off switch separate to the inverter in a more convenient place. And it gives you the same information on the screen that it would. In fact, you can take the same screen and plug it in. We actually had someone that lost one of your customers down in Cape Town, Mark. He did that and he lost it. So we had to get another screen for him, but they're available. Then we have what's called a current sensor. You can, we have one here. Oh no, this is a battery shield, sorry, the current sensor. The current sensor plugs into the inverter. There's a terminal on the inverter where you plug it in, and that then will give you, on the inverter, it'll tell you things like how much current, how much battery life you've got, all that kind of stuff. But it works in conjunction with the inverter. Okay? Then we also have a battery shield, which you can program to where you want your second battery, your auxiliary battery, at the lowest to drain to. So if you want your auxiliary battery to go down to about 11.5 volts maximum, you can then program this, and this will then protect your battery. Okay, so it's a battery protection system basically, but it's something that you can fit and forget. That's your battery shield. And then this is the tech hub. Okay, we've gone through this tech hub. It's got eight terminals plus one. This one over here isn't protected with a relay or with a fuse. It's for the remote. So you plug your remote into that, and that's got a lithium battery inside. You can mount it where you want. It charges while you're driving, charges while you're not using it. It's got little stickers in there to put on to allocate the different buttons to different accessories. And if you don't want to use this, you can also take this cover off. This cover here. That's a cover there, and there's 8 switches behind that cover, so you can use that as a second on-off system if you locate it in a convenient place. This is new to us. We've only just introduced it, and somebody at Megaward is busy testing it for us at the moment as well. All right. Have I covered your battery systems? Is there something I've missed out? Any questions?
So, an average acceptable setup, how much will it
I don't know, I can't tell you. And I'll tell you why. There's so many different components in the system. It would depend on what you want and what brand you want. Because you can buy, one brand's going to cost more than the other. But if you're going to fit a ring system at retail value, probably close, if you're going to go for the full thing, for everything, solar, the whole bang shoot, probably close on 20,000. That will give you a dual battery system with one battery. It won't give you 2 batteries, but you'll probably come close to 2 batteries. Again, it depends on what you want. Very difficult to say. It depends. Do you want the tech hub? Because the tech hub will save you a lot of wiring and installation time. But there's a cost to it. Probably offset by the amount of wiring you're using, or that you're going to save, and the time that you're going to save in terms of the installation of the system. there is an offset there, but it depends. You've got to decide on what components you want. But I would say if you want to start budgeting, start at 20,000 Rand for a decent system, a good system. No questions, I answered everything. Satisfied everybody's needs on a dual battery system.
These flexible solar towers, if you mount them on top of the roof thing, then
Yes, good question.
don't they wobble or
If you mount them on top of that,
rooftop thing? So
if you mount them, permanently mount them. Okay, the first thing is, if you're going to permanently mount these panels, you have a sticker on here that tells you you must mount it onto Corrie board first. And we've chosen Corrie board because it's the cheapest basically, but the most flexible material to use because it's got air gaps underneath it. It's like a plastic cardboard. You know the estate agents use them to make signs. Mount it on there because you need an air gap underneath. All panels need an air gap. If you mount it onto aluminium, what happens is in a hot region, the aluminium heats up, the solar panel heats up, and the electronics burn out. Okay, you can throw it away. We've had a lot of that where people have mounted them and it hasn't
Where
been
do you mount
successful.
it to?
Sorry?
Where do you mount it to?
Well, the top of a rooftop tent, you can mount it on top of the aluminium rooftop tents.
Actually got a piece of correct itself.
I don't necessarily agree with that because you might as well just put a glass panel up there and just hope it doesn't hail. But these were designed specifically when I put mine on top of my what do you call it? My awning. I just plop it on top of my awning. It's not heavy. It's not going to pull the awning down. And that's what it's meant for. It's meant to be convenient. It's meant to be simple to use.
And it can withstand hail.
You can drive over this thing. I've seen a car drive over this. I have a Land Rover Defender, and I use this because I don't drive it all the time. So the batteries, they tend to go flat after a while. So I keep them charged with one of these at home. But the problem is I've got to remember to unplug it before I drive away, which I haven't done on a few occasions. Now before, because now I've got it on my sort of the roof tied down because of wind and whatever, and the cable I just plug it in the back. Before that I used to have it on top of the Land Rover roof. And I used to drive away with this thing still connected. Got to the main road and the wind would pick it up and blow it off. I've seen a car drive over it. I've seen it hit a car. The second car hit it. That panel is still working today. They're very tough. From that point of view, they are tough as nails. They'll certainly outlast any glass panel.
Well, what size panel would you need to run a 40-litre engine?
An Engel, okay, so the accepted equation on panels is if you're running a 100 amp hour battery, you need 100 watt panel. Now depending on how long a 40 litre Engel takes to drain a battery to 50%, because that runs at about what, 5 amps? 2.5 when it's running, 2.5 amps. So you've got 2.5 amps. So your battery will last you about 12 hours. 12 times 2.5, no, a bit more, 15 hours. 15, 30, 20 hours. Let's call it 20 hours.
And it also depends on how many times you use your fridge and how many times you open it for the
Correct.
compressor that's going to switch on.
But we're saying if we don't open the fridge, because every time you open the fridge it kicks the compressor in, that's going to drain the battery. But that's also working on it running basically on an average. So you're looking at about 30 hours, and this is 6 amps. So you're putting in more on a good day. But remember, you've only got about 4 to 5 hours of good sunlight on a good day. So you can put in 6 amps, 5 hours, 30 amps. You're certainly putting in about the same as you're taking out on a cycle, on a 40 litre Engel, on a good day. And this is the thing with solar. If you've got cloud cover, that's not a good day. If you've got pure sunlight, and you've got your panel at the right angle facing the sun all of the time, that would be a good day. Okay, that would be optimizing the panel. But if the panel's not facing the sun all the time, you're losing already. Okay, and you've only got about 5 hours, tops, on a good day, for solar to work. You've got to put in more than you get. So if you're taking 2.5 out and you're putting 6 back in, you'll win. You'll win. But there needs to be discipline exercised with your fridge. If you've got kids, you've got to keep them away from that fridge, because every time that thing, I always say, it looks like a crocodile. It's open and close, open and close. You need to exercise caution. And just some simple disciplines. I mean, we've become disciplined with load shedding. We all can handle load shedding, pretty much. It's no different with your fridge in the bush. No different. You just need to have a couple of rules in place to save power, because the problem is if you end up losing power more than you can put in, you're only heading this way. That meat is going to defrost and that beer is going to be warm. Two biggest sacrileges of a trip. You don't want that. Warm beer and defrosted meat is not good. Okay.
Mark, can I just, I want to ask you a stupid question. I suppose it's not a stupid question, but in my case, I've got a 100-watt panel. Alright? So that's enough to maintain my battery. It's not going to charge my battery.
No, you can charge it.
But it's not going to charge magnificently. In order to charge that battery,
Only it will, depending on the sun.
yeah.
I charge my Land Rover. Sometimes if I don't plug it in,
Here's your problem.
it doesn't kick over. But if I plug it in for a day or two,
Yeah.
it charges that battery right the way up.
But
I
it's
can
not
watch it on my
going to
meter.
fill it. It'll charge it to a certain point, but it's not going to fill your battery. And I think a lot of times, especially modern day or the new cars, like your Hiluxes, maybe I should stay in the front here, and the Hiluxes and the Fortuners with their smart alternators, because it drops the amperage output that you're using, you have to use the DC to DC charger. But let's go on an older vehicle like we have on the D4D Hiluxes and stuff. The guys still get away with a solenoid system.
On the older ones.
On the older ones. But the solenoid system will never charge the dual battery or your second battery full.
No, and there's a good reason for that. The reason is that on an old system, your regulator is making that decision.
Yeah.
Whereas on a smart alternator, the vehicle CPU is making that decision.
Yeah.
Not the regulator. There is no regulator anymore on those ones.
Yeah.
So it's all been made by the CPU. It's telling it when to drop the current
Amperage or whatever. So would you say it's better to, even if you have an older model like that, to use DC to DC, because DC is going to fill my battery at the end of the day, because a normal solenoid system is not going to fill the battery.
Yes, you're quite correct from a DC to DC charger point of view, but not from a PV point of view, not from a solar point of view. Because remember, solar is not running through your alternator. Solar is at the back end of your system, running through your DC charger to your second battery. It's got nothing to do with the alternator.
Okay, but let's forget the solar for now. So if we're running just a normal dual battery system, if I've got a solenoid system, like on the older cars with the older alternators,
Absolutely.
the battery is not really being charged fully.
No.
And even though you have a management system on there that's got an indicator, it's going to show that the battery is fully charged, but it's not fully charged.
That's correct.
The only way to fully charge it is to literally put a charger on it. Whereas with a DC to DC charger, it will actually fill the battery.
That is quite correct.
Am I right if I say? Okay.
If you take PV out the way, you're quite correct.
Who's PV?
So, no, that's quite correct. No, a solenoid will not charge a battery.
And I think a lot of people have that misconception that if you've got a solenoid system, when the system shows that the battery is fully charged, it's not fully charged. And you expect that battery to give you the exact same performance as if it would be fully charged. And you can't understand why the battery is not lasting. But the bottom line is the battery is not fully charged. Whereas if you run it through a DC to DC charger, at least I know my battery is fully charged.
And you'll pick that up if you go into the game reserve, because where a solenoid system will show its ugly head if you've got a smart alternator, because you're traveling now at low speed, the car's central system is going to start cutting down that amount of battery that it needs, or battery from the charging from the alternator, because it's already charged. It's charged up, so now it starts backing off the alternator charge down to 11.1 even on some vehicles. But your solenoid needs 13.2 to kick in. So now you're battling around the game reserve at 20 k's an hour. The solenoid's not opening to charge the second battery. And you'll get back to camp and nothing's happened. You're wondering
And your
why.
beers are
Why is your battery not charged up? Because that's why you're driving. It's because in the camp you've drained your battery. Now you need to charge it. So you've gone for a drive and nothing happened.
I just think at the end of the day, the fact that technology has developed to the point where you can run a normal DC to DC, even on the older cars, it's a better bet to go that route at the end of the day. I'd rather use a DC to DC and I know my battery's full constantly, than run the risk of having a battery that's 3/4 charged.
And while we're talking about solenoids, guys, don't put a solenoid in place before a DC charger. Because you're also going to cut out the DC charger from working.
Can I ask something? What is the fastest charge of battery? What, the solenoid or the DC-DC?
DC to DC. Depending on the capacity of the DC to DC.
Depending how fast you're driving, how long you're driving.
Yes, yeah.
So even
Remember-
if you drive 4 hours a day, overland,
Yeah.
what will charge the battery the fastest? DC-DC or the solenoid system? If you can take a solenoid.
If I had a choice,
Yeah.
I would take a high capacity DC charger. That's the way I'd go. Because you're getting 30 amps. And there's some coming that are going to be even bigger. And CTEC have that bolt-on thing that can even give you more. Smart parts, yeah. So I would rather go that route than go solenoid. Really, I would. You've got more control.
I just think
You've
solenoid
got more
at the end
control.
of the day is old tech. Yes, it works, but it's old technology. It's like having an iPhone 1 versus an iPhone 10. The technology is there, and if it's there, use it.
And another question if I can ask, the batteries. If your charger can give 30 amps, what battery must you use to take that 30 amps? Because all deep cycle batteries can't take 30 amps.
Yeah, but
It takes 10 amps an hour.
you must remember, the battery will only take from the charger what it can take. Now, if your battery is depleted, let's just say you've run a battery overnight and somebody left the fridge open and your battery's sitting at, say, 20-30% now.
Yes.
It will take 30 amps. It
Any
will
battery?
take a lead acid battery. Because that's what most of us use. Okay? A lead acid battery will take 30 amps, 100 amp I'm talking about. Okay? Because it's been depleted. But as it starts getting fuller and fuller and fuller, so there's more resistance that's been built up, which means the charger will start backing off its charge. It works like a smart charger for home. It works exactly the same way. It works on resistance. So as it starts getting fuller and fuller, so the amperage comes down that's going into the battery, to the point where it's actually just maintaining the battery.
It goes into a limp.
We didn't touch on it here, but there was a product I saw right here in this joint, and it had a thing that looked like a battery, but it wasn't. And this is something you can charge, and I think the guy said it doesn't need any of these components. Like it's like a big power bank.
It's almost like
It's got plugs.
It's a battery pack. So
It's
it's
a
got its own
battery
chargers built into it.
Yeah, but
and
it
that kind of
wasn't
thing.
like it's small, so and.
Yeah, it's a lithium battery.
Yeah.
Under the counter.
It's a lithium battery pack basically. So the battery will be much smaller.
What do you think of it?
Yeah, so you don't need that one?
It's easy for load shedding.
Oh, okay.
It's the best place to install glass containers and the best place to install all the electronics.
Okay.
That is it.
This DC charger is not solid state. Okay?
Yeah.
So it's got fans inside, it's got 2 fans inside, and it draws air into cool electronics. Okay? The biggest killer of a DC charger is heat. Alright? Most of the others are solid state. They can be fitted in the engine, but you can't fit them anywhere in an engine bay. You've got to fit them ahead of the radiator because you need cool air to pass over them. If you fit them at the back of the engine bay, it will eventually fail. It may not fail on your first trip, but it will eventually fail. It eventually will have so much heat and it will deteriorate inside, it will eventually fail. So if you want to fit a solid state type DC charger, you can, but just remember, you've now got a long way to travel with cables and all that kind of thing. Ours are more suited towards being fitted in the back of a vehicle, whether it's inside the vehicle or in the back, or in a trailer, in a caravan, that kind of thing. And you cannot fit it into the front because it's going to suck in air, it's going to suck water, it's going to suck in dust. It'll kill it in no time. So, to answer your question, anything with electronics should be out of heat number one. If possible, out of dust, excessive dust, protected from excessive dust and obviously moisture and
All of those things considered,
Does it
matter
It's like a
placing your
battery
charger in the engine bay cable length-wise?
I'll show you now when we're
No,
done.
you can do
You've got
it.
your battery in the front and you've got the battery in the back.
Yes.
Not a vehicle where you can fit both in the
No,
front.
you can. You'll get away with it, but you need to make
Is
sure your
there a
cable
difference?
is right.
Okay.
Your cable thickness, because you'll end up with a voltage drop. So you need to increase the thickness of your cable to accommodate that voltage drop. Or what's going to happen is your charger is going to be boosting it even higher, and it's going to run on a higher voltage the whole time, or amperage on the whole time. Which also you don't want. You want it to control itself so that it can work properly.
You guys got questions? Next thing you know.
Sorry, I was handed this. This is Corrie board. Okay, so if you mount a panel on this, you can see it's got air gaps underneath. There is a different Corrie board, which is a little bit, it's a bit thicker, which is probably a bit more suitable for, depending on the heat.
When wiring a dual charger, where do you take your power from? Is it better to take both your positive and negative from your starter battery?
I would recommend it. I know some people use the bodywork for the
Do
negative.
you use the body
Yeah, I've seen
to
that happen
tap
as well.
it into, especially on your negative?
I would run it from the battery. That's the way we've been told by Ring.
Or should you do alternate?
No. No, run positive negative from the battery. That I would recommend. Have you got anything different?
That's why I'm asking, because
I've seen negatives go to bodywork, I've seen negatives on alternators.
exactly
I
why
would
I'm
rather put
asking.
it on the battery, because your battery is also a protection system for you. It absorbs spikes and things like that. Whereas if you take it off the battery, you can't control that as well.
Any other questions, guys?
Why did you say the solenoid system on a DC to DC?
Because people use them as protection systems because they want to protect the main battery. So they put a solenoid there so it stops. It's, you know, when you turn off, it doesn't, the DC charger doesn't now start pulling from the main battery. So in the morning, they want to be able to start their car.
Yes.
But what happens is the solenoid system actually disrupts the operation of the DC charger. This DC charger here, you can set, okay, for, first of all, your bulk charge, depending on your battery technology, because remember, what determines your technology is not just the chemicals inside the battery, it's also your charge rates, okay, your charge algorithms. So if you take an AGM battery, 14.2 is maximum bulk charge voltage, 13.2 is your float. But if you've got a lead acid, it's 14.7, 13.6. So you can change it on that one to accommodate the battery technology. The other changes you can make is your cut-in and cut-off values. So you want the charger to stop taking from the main battery at a certain voltage. You can set that voltage. So if you've got a brand new battery and you're wanting more power, you can take that charge down to say 12.5. But if you've got an older battery and you want to protect it, take it to 12.8. Okay, so at 12.8, they disassociate it from each other.
So I've got an older vehicle which had a solenoid system in, and then I got hold of a DC to DC, put that in, but now obviously my cable is this much too short if I have to cut the solenoid out, so I just left it in.
Yeah.
I was under the impression it's like just a cut-off when you switch the ignition off.
But it's now working with the cutoff of the DC charger, and you could find you've got a positive and a positive equals a positive, a negative and negative equals a positive, negative positive equals a negative, and that's what you'll end up with that. You could actually end up with that solenoid opening and sucking power out, taking it to the back battery. That's why I say take it out, because these things are there to accommodate that.
Since no one's asking, I'm gonna, what happens when you connect two auxiliary batteries? How would you connect that?
Awesome question. Okay.
Sorry, because
No,
that is
that's it.
technical.
I had it in my head to bring it up and I forgot about it. Somebody distracted me and I forgot completely about it. If you've got two batteries, two auxiliary batteries, okay, and you've got one DC charger, let's just assume you've got them connected in parallel. In other words, you've got a positive and a positive connecting the two batteries and a negative and a negative. That's just the batteries connected, okay? Now you've got to take out and put in power. So you've got 2 terminals per battery. What you want your chargers and your inverters as accessories to see is one battery. So you would put one positive from the charger now. You would put a positive onto battery A and the negative onto battery B. Because now it sees it as one battery, so it'll charge both up at the same time. Alright? Your inverter or your accessories or your tech hub will go on the opposite positive and negative of those 2 batteries. So it will drain them together as well. Because what will happen is if you put the positive onto and negative onto one battery and the positive and negative onto the other battery for your accessories, it will drain this battery to 100% before it starts sucking out of the next one. So your first battery will have a very shortened lifespan. You follow?
But with them connected in parallel, does it?
Connected in parallel makes it seem like one battery. If you connect positive onto one, negative onto the other.
Yeah.
It'll see it as one battery, not as 2 batteries. Which is why in parallel you've got to have the same size batteries.
Yeah, same
Can't
type,
mix up
same
the
size,
sizes.
same age.
Yeah, you can't mix up the batteries.
Because otherwise it's going to
Otherwise it's gonna pick up a difference,
the
yeah.
oldest one.
So that is the way I've always recommended wiring it up. Positive on, negative on the other battery, and take it out. Positive on the one battery, negative on the other.
So
that you're draining them at the same rate as well. And then you'll get much longer lifespan out of it. And I know it's a little bit more wiring because you've got to connect up the 2 batteries, and a trailer you may have one battery on one side and one battery on the other, but they'll last longer.
So it's not as simple as actually just adding it on with
No.
So you'll still connect your 2 batteries
Yes.
directly, positive, positive, negative, negative,
Yes.
but your charger goes positive, negative on the other one.
Correct. And your inverter goes negative, positive.
On the other 2 terminals.
On the other 2 terminals that are left. Yeah. Yeah. Excellent question. Sorry, I'm glad you brought that up.
Yes.
Because 24 volts actually, believe it or not, is actually it's more efficient. But you've got to have the accessories that run on 24 volts and all that kind of thing. So it's not a simple just run at 24 volt. I know in my house my UPS is all run 24 volts. So because I'm going to run 2 batteries anyway. So run them 24 volts. It's more efficient. And again, on my UPSs at home, because I've got 2 batteries, I wired it exactly the same way. You've got your negative and your positive joined in the 2 batteries, and your negative from the UPS goes onto the one battery and your positive goes onto the other battery.